All right, let's look at question number 6 on the 2021 BC exam. I have not looked at it yet. I assume it's a Taylor series question, and it is indeed a Maclaurin series, a bunch of sigma stuff in here. All right, let's see what we have here. So the function g has derivatives of all orders. They give you the summation notation, the sigma notation for g of x within its interval of convergence. State the conditions necessary to use the integral test to the, we have to use the integral test of all the, it's my least favorite. All right, these little turd monkeys. All right, so the conditions necessary to use the integral test is that your function, in this case, we're only showing the integral test for e to the n. Why do we have to use the integral test for that? That's a geometric series. Geez. Okay, well, we have to show that the function is positive, or they don't say show it. They just say state the conditions. All right, so f of x, we're going to use the function 1 over e to the x is positive, decreasing, continuous, and decreasing. That is what you want in order to use the integral test. And so we have that, and therefore the integral test, we have to do the limit. We have to do this as an improper integral. The limit as n goes to, not n, I'm going to say t, goes to infinity of the integral from 0 to t of 1 over e to the x dx, which is going to be kind of nice because the integral of 1 over e to the x, that's e to the negative x. And that integral is going to be negative e to the negative x. So while I hate the integral test, it is my least favorite of all of them, at least I gave you a nice one. So that's negative e to the negative x for the antiderivative, which is negative 1 over e to the x. We'll evaluate that from 0 to t, which is going to be the limit as t goes to infinity of negative 1 over e to the t minus negative 1 over e to the 0. Negative 1 over e to the t will approach 0 as t gets infinitely large. And so this is equal to 1 over e to the 0. That is equal to 1. Therefore, we now know that our series n goes from 0 to infinity of 1 over e to the n converges by the integral test. Use the limit comparison test with the series 1 over e to the n to show that the given series converges absolutely. Okay, so to show convergence absolutely, I need to label this as part A. Okay, so absolute convergence, I'm going to do, so the limit comparison test, okay. 0 to infinity of the absolute value of the series in question. And that would just give me this series, 1 over 2e to the n plus the limit. Why are they wanting me to use the limit comparison? I can use direct comparison. Man. Not a fan. Oh, this is a different, yeah, I can use direct comparison. Oh, whatever. We have to use limit comparison. All right. So we have to do the limit as n goes to infinity, and we just have to do the ratio of this series to the 1 over e to the n in any way. So I'll do 1 over e to the n on top over 1 over 2e to the n plus 3. And we just want to show that we get a positive finite result. So that's 2e to the n plus 3 over e to the n, and that will give you a limit of 2 that is greater than 0 and finite. Therefore, my series negative 1 to the n over 2e to the n plus 3 converges absolutely. The only thing I'm wondering about this question, to know that this limit was 2, I realized that this, we could have used STDs. That probably would have been easier. It could have been L'Hopital. I was wondering if they wanted us to go through L'Hopital's rule, but if you separate this limit and add a couple of extra steps in here. So maybe from here I did limit as n goes to infinity, and I split this. I call it an STD, a single term denominator. 2e to the n over e to the n is 2 plus 3 over e to the n. And then 3 over e to the n will approach 0, which then ultimately gives you an answer of 2. So we could have done that way to be a little bit more mathy in how we knew the limit was 2. Let's go on to part C. Determine the radius of convergence for G. All right, so this one is actually probably nicer than the first two. We're going to use the ratio test. I think, where's G? Yeah, so anytime they ask for radius of convergence, always consider the possibility that you are looking at a geometric series, but the function G, or the series G, is not. The series G is not a, this is why I'm trying to talk and try to work at the same time. I stutter. G is not geometric, so I'm going to have to go with the full-on ratio test here. So that'll be -1 to the n plus 1, x to the n plus 1 over 2e to the n plus 1 plus 3 times 2e to the n plus 3 over -1 to the n, x to the n. And this is an interesting one. Usually things cancel out a little bit more nicely than this one. So -1 to the n will cancel all of those. The absolute value will get rid of that -1. I will have one more x on top than I have on bottom. And so I'm left with the limit as n goes to infinity of the absolute value of x times 2e to the n plus 3 over 2e to the n plus 1 plus 3. And let's talk about this one for a little bit. E to the n plus 1 and e to the n. What would that approach? What would that do? What do we think? Oh, hang on a second. All right, sorry I had a little interruption there for just a second. All right, so this one right here is a little bit interesting. Let's see. The denominator has a slightly higher, that e is slightly higher. What I'm going to do with this down here, and I'll do this in baby steps, n goes to infinity. I have absolute x. I'm not going to touch the top. In the denominator, I'm going to change 2e to the n plus 1 to 2 times e to the n plus 3. I'm going to separate that n plus 1 like this. So now that I'm looking at this, hopefully we all can agree that as n is getting infinitely large, these 3's are insignificant. So I'm really comparing these two, and it's essentially the same term. It's like having two terms of the same degree. This limit is going to equal absolute x times that constant. The e to the n's are equal. Those plus 3's are insignificant. So the answer to the limit, and boy, I really butchered explaining that verbally, but it's 2 absolute x over 2e. We need that to be less than 1 for the ratio test to show convergence, which is going to be when absolute x is less than e, and they are asking only for the radius, not necessarily the interval. So the radius of convergence is e. How do I misspell radius? That was impressive. Radius of convergence is the constant e, 2.7182818284590452353. Number D. The first two terms of the series law are used to approximate G of 1. Use alternating series error bound. Oh, this is a nice one. This is a nice one. So they did not go Lagrange. They almost always ask for an error approximation question, and this time they went with the alternating series error test. So G of 1, which is the series, -1 to the n, 2e to the n plus 3. Ooh, let's not confuse that plus 3 with being part of the exponent. And we're going from 0 to infinity. So what they say is the first two terms are used to approximate G of 1. So my first two terms, when I plug in 0, that's going to be 1 over 5 and it will alternate minus 1 over 2e plus 3, 2e to the first plus 3. And then the error, if it's an alternating series that converges, which this is, the error is always less than the magnitude of the first omitted term. So as it alternates, that's going to be a positive 1 on top. And then if I plug in 2, that'll be 2e squared plus 3. And so I want to state that the this series, the series for g of 1 alternates, I'll say is an alternating series whose terms decrease in magnitude or you can say in absolute value or something like that, to 0. Therefore, the maximum error is less than the magnitude of the first omitted term. So in this case, the maximum error is going to be less than 1 over 2e squared plus 3. And that's it. There we go. We have question 6 done.